One thing I forgot to point out from the morning session was I went into this first problem in the homework set and added one feature to it. So I added a get a new version of this problem button to the homework set. And if we click that problem, you'll notice that we'll get a different set of random parameters here, and we could do that any number of times if we wanted to try this problem again and again as a student for practice. That's like the show me another option, but the manual version of it, where you have to insert it into a particular problem. The show me another option, I believe, is sort of a course-wide option. Correct me if I'm making a mistake there. Let's go ahead and show you how to do that. Look at the problem source. It's actually very easy. David Cerrone has written a macro problem randomize, and you just have to issue one command to get it to run, and there are many options to as to how to configure this thing. When do you want it to run? Only after the answers are turned in, or only after the due date, things like that are the options. And I'm not going to spend time going through them right now, but if you Google problem randomize and WeBWorK, you should be able to find the HTML help page with all those options listed. Okay, so here in this very first question is something that I wanted to implement probably 5 years ago and didn't get around to implementing until this year. It's writing a macro that redefines trig functions so that they are evaluated in degree mode. And so students can type their answers in degree mode. WeBWorK authors can write things in degree mode. All that's required is to load a new trig degrees context. And I should add, as I've said before, you should thank David every chance you get. And this is one of those times where I had figured out several years ago how to redefine these functions in a bad way. Meaning is kind of a hack, and it was done one problem at a time, and I put something together as a macro, as a potential macro, and sent it off to David with some questions, and he was amazing in helping me turn it into a much, much better macro. So in particular, let's have a look at the problem source. It defines a new context called trig degrees, with a corresponding macro file, and basically you just have to load that with all of David's improvements. You can do things like take derivatives of these trig functions and so forth. So yeah, just shout out to David for being awesome, I guess. One thing I do want to point out here is I inserted some text that took the current context and obtained an array from it consisting of all the names of all the functions in the context. And I joined all the elements in that array by commas. And using this very basic text command, right, there are several ways to insert text that gets displayed to students. There's the begin PGML, end PGML. There's the begin text, end text, and their corresponding hint and solution statements. This text, I think, was probably one of the very first WeBWorK macros ever written, or probably not even a macro, probably a Perl module written to display the text to students. So it's a very basic utility. It doesn't really do any interpreting of the text that you pass it, right? One of the things that makes David's PGML so awesome is that it goes through and interprets things like plus as, a new list item. And, it interprets this command as, oh, typeset things in math mode. But this text thing is not doing that. And so, I left this in here just to show you that it's possible to print things out in a different way. and you can see the list of all the functions here that are available in this particular context. So it's not really a production level problem, it's more of an instructive problem. Earlier we were talking about embedding music videos and other things to jazz up our experience with WeBWorK and appeal to learners of different types. One of the things you might want to do is to include some, or to embed some content, like something from a Google slideshow, or a YouTube video. And how would you do that? Well, HTML provides an iframe command that will essentially construct a sort of self-contained container into which you can put content from other websites. And you saw that once already today in Mike Gage's presentation about embedding WeBWorK in an ordinary HTML page. They were using an iframe together with some special commands to actually embed a WeBWorK problem in an ordinary web page. So there's not a whole lot to note here except how to construct these things. You want to define a mode-dependent variable, something that's going to do different things in HTML and in tech modes. And essentially, you're just using a low-level HTML command, the iframe command, and inserting the web page with the content you want. And in tech mode, you're basically telling students what is there. And then to insert it in PGML, it's quite straightforward. You just need to go to Perl node, and in that Perl node, you put your mode-specific or mode-dependent variable content in there, and then interpret the results properly with the right kind of substitution, and you can go ahead and use these double arrowheads to center things. So let's actually see what the source for that file looks like. So I think I mentioned this last week, but I'll mention it again. With these slides that I wrote, they have some special stuff in them. So if you see comments like this, you want to make an ordinary PGML or PG file out of this, not a slide file. You'd remove this thing, you'd remove this slide stuff, you'd follow other things that say uncomment, right? So uncomment that, and so on. Okay, so to the mode-specific variables, as you can see, one of them named slideshow is mode-specific, and in HTML mode, we are just inserting a raw iframe with some properties like no border and a certain width and a height. And in tech, we say there's a slideshow there, and we don't actually print anything. I suppose we could take a screenshot and put an image in there, but I'm not sure it's really worth it because we really intend for people to experience this content online rather than on paper. And then a very similar thing with the YouTube video. It's an iframe HTML tag with some width and height parameters and a source parameter and some other YouTube-specific, probably, well, no, these aren't YouTube-specific. This one might be YouTube-specific. But it's, as you can see, pretty straightforward to do the coding, and inserting it is also very straightforward. Okay, some of you in your homework problems from last week did an awesome job of inserting some answer format help links, things like these links that appear off to the side, well, typically off to the right side of an answer blank. You can insert them wherever you like, but next to the answer blank seems like the most natural spot. And when a student clicks on these links, they'll get some help documentation that is, I think, very useful for students who are initially apprehensive about how to use WeBWorK and things like WeBWorK. It also contains some, very specific instructions, things like, oh, square root's defined, but, cube root's not, things like that. It'll also instruct them on what to do in exceptional cases. So in general, these help links are useful. Students tend to get used to how to do WeBWorK really quickly. So the help links probably go unused for much of the semester, but nevertheless, it's important to support our students as they're learning these things and trying them out for the first few times. And the help links are one way to decrease student frustration. So as you can see, there are many different answer format help options that you can put in there. This particular question was using numbers, but you could have typed in logarithms inside the quotes when you do the answer format help call, and it would have given you some helpful things there. So you can look at the source. Answer format help links are, I think, a good idea in general. They're easy to insert, and yeah, if you put them into a template and make sure that you keep updating that template when you write new files, then you'll just kind of get your answer format help links in there pretty easily and quickly as you write problems. Another way to provide content, additional content to students is through something that John Jones and others like to call knolls, which are little bits of knowledge. And so a knoll is a link to a little JavaScript drop down, and you get to specify what sort of text you want on the link and what sort of text you want in the drop down. And as you can see in the syntax is actually very straightforward. Knolls are built into the basic macros of the WeBWorK system, so you don't really have to load anything special to get them to work. And the problem source here is almost unexciting to look at. I mean, it's literally, we drop into Perl mode, use this null link subroutine with the link that goes on the text, the text that goes on the link, as well as the text that goes in the dropdown. So the answer hints that we saw last week are a lot like the nulls in how they function. Okay, now a little bit about internal and external links in WeBWorK. An external link would be, for instance, something to Wikipedia. And those are pretty straightforward to call, as are internal links. But with internal links, what I mean by internal is you are trying to link to some resource on that particular WeBWorK server itself, not the broader web. So, for instance, this particular link takes you to the course that we're in, the 2015 Prep Problem Authoring course, and then there's this videos directory that I created with a Flash video in there, and you can go ahead and view this several years old video if you want, showing off some of the WeBWorK questions I wrote. So let's actually take a look at the source code, and then we'll come back to the file management in just a second. So in the source code for internal and external links, there's nothing special you need to load. In the PGML display portion, you want to drop into Perl mode and interpret things properly. And there's an HTML link command which takes a few arguments, one of them being the actual URL, universal resource locator, the text that goes on the page that is what the students would click on, and then some optional parameters you would pass via HTML. So this target blank option that I have here, what that actually does, if we go back here, the target blank option opens the page in a new window or new tab. Okay, similarly, the only thing that's different for internal links is that you will call an environment variable called HTML URL that WeBWorK knows about. Okay, so where does this environment variable point to? It points to the course HTML directory, and I'm going to go back to the slides. Okay, so I'm going to walk through steps 1 through 6 here on the slides, but it's going to take me away from this page. So if I open a new tab here, that course HTML directory, you can get to it by clicking the File Manager, which opens by default in the course templates directory, and then you can either choose to drop down a directory to the problem authoring directory, or I could have alternatively clicked the little caret button here. In either way, it took me up a directory. You can now see where we were in the templates directory, and I want to go into the HTML directory. And in that directory, I previously created a new folder named Videos, just to try to keep things organized. And then I chose this SWF, which is a Flash video file. I just used the Choose File option and uploaded it to this Videos directory. And then going back to the problem source, you can see, where is it? There. You can see that the Videos directory that I created and put that Flash file in there is the extra stuff that needed to be appended to the HTML URL, which was, again, if I can go back here, that HTML URL environment variable is referencing this entire web address for you. So don't hard code that web address. Instead, use that environment variable. So I think last week I showed you a custom grader for a question that had maybe like 8 true or false questions, true or false parts to it, and we assigned differing amounts of credit based on how many questions students answered correctly. And this weighted answer grader slide is going to do a similar sort of thing, but it's going to weight each answer blank separately. So we need to load a weighted grader macro file. We need to issue a command that says, hey, use this weighted grader, and then actually use a special answer recording or score recording routine called weighted ants instead of just ants. And we also need to specify the percent that particular answer should be given, the weight that the particular answer should be given. Okay, so let's look at the source. And here we've got the macro, and we install that weighted grader. And then how do we actually use it? Well, in PGML, I think maybe the easiest way to use it would be to use formatting that is reminiscent of the older style WeBWorK problems, where you create the answer blank in the text portion, but you wait to actually do the answer checking until you're outside of the PGML text display portion. Okay, so answer 1 is going to be given a weight of 40%, 40%, and 20% for that pop-up, whether or not this is a circle or an ellipse. Okay, suppose you wanted to ask a question where it didn't really matter what order students entered their answers in into several answer blanks. There's a macro for that, not surprisingly, unordered answer. And the unordered ans subroutine is going to take care of all that for you, and all you need to do is pass it a couple of answers that have been processed by the comparison method. So in the problem source itself, it's pretty straightforward. We load the macro, and the only extra thing we have to do is in processing the answers. Notice that in the PGML, I did not put the answers in. Instead, I'm having the answers here for the first answer blank and for the second answer blank, and then the unordered answer checker. Right, so for instance, what is the correct answer for this? A correct answer would be x over 4 squared, y over 5 squared, each of those quantities squared. That would be one correct answer. Another correct answer would be if we were to enter these in the other order and submit the answers. That's also going to be marked correct. And if we tried something else that's silly, we're going to get marked incorrect. Okay, now not every question is going to have an answer that is an expression. We addressed equation answer checkers last time for a specific kind of equation where it's of the form y equals something or f of x equals something, in which case the left-hand side of that equation is just kind of an expression that's a placeholder. It's not really something you'd need to do answer checking on necessarily. You just need to make sure that it's there in the right form. This parsed implicit equation answer checker is going to deal with equations that are much more involved, right? Where you actually would have to do some answer checking on both sides of the equation, and it uses numerical methods to do the equation solving, and these numerical methods do have their limitations. So, for instance, if a question is asking enter an equation for the unit circle, x squared plus y squared equals 1, and you wrote this implicit equation answer checker well, it would mark x squared plus y squared equals 1 correct. However, that's not the only answer that would be marked correct in that case. So envision taking the quantity x squared plus y squared and squaring the whole thing, like squaring the left side of that equation, and then setting that equal to 1. Then that would also probably be, if you had a good answer checker on it, would probably also be marked correct by this implicit equation answer checker. Now, this implicit equation answer checker can cause you to lose your hair. It is very fussy because these numerical methods do have their limitations. So one of the things you'll want to do is test these out a lot with all the different randomizations that you're going to use for the problem. This is a very sensitive answer checker. You want to make sure that it's reliable by testing it a lot before you put it into production. So one of the things you can do is to set the solutions. You can enlarge the domain for the variables, things like that. And so let's actually dig into the code, the source code for the problem. And it's pretty straightforward. We load the equation answer checker, and a bunch of formatting flags that I set. I decided that the limits for answer evaluation should depend on how large A is and how large B is. This is going to generally improve the accuracy of your answer checker. And for this particular equation, I provided a long list of solutions, and I provided a relatively forgiving tolerance as well. And other than that, everything else is basically standard, right? Once you've created this implicit equation object, you just do the answer evaluation as normal. Okay, you can set up custom answer checkers for anything, but in particular, one thing you might be interested in are equations. So, for instance, you could write a subroutine and pass it as one of the arguments to this comparison method for checking the correct answer. Okay, so the subroutine that does the answer checking for you is going to harvest the correct answer, the student answer, and a bunch of answer checker parameters stored in answer hash. And you can harvest those parts of the student answer by lopping off or getting the left operand in the tree structure of the answer as parsed from the student. Okay, so this will be the left side of the student answer, and similarly use the right operand to get the right half of the student equation. Inside the custom answer checker, there's really no way for you to print things other than to set a warning. So for debugging, warning particular values, we'll actually print them to the screen, and that'll be very useful. You should also be aware that you want to exclude particular kinds of answers. So you want to make sure that the student answer is or is not constant, or things like that. This particular answer checker that I wrote checks the student answer at 11 different points. And let's go ahead and look at the problem source. So I loaded implicit equation and constructed the object using implicit equation as before, but instead of using the default answer checker, down here I created my own subroutine for doing the answer checking. Get the student answer and its left portion and its right portion of the equation. If I wanted to get some feedback on what those actually looked like, I would uncomment these warnings. I want to make sure that the student answer, so the student answer is formula will return true if the student answer is non-constant and is actually a formula. And we can negate that value and do some logic, some Boolean logic tests, and weed out bad answers. Then I went through and created a score tally and looped through 11 different values of I, and I evaluated the left side of the student answer at those 11 points. So I literally parameterized this ellipse and substituted values in to that parameterization, and did that on both sides of the equation, right? So for both stu1 and stu2, the left and right sides of the equation. And if those two things are equal at a particular value of I, we'll add 1 to the score. And then if all of those points check out, then the total score should be 11, and this will return a value of 1. And if the student has an incorrect answer, then this Boolean statement should evaluate to 0. Okay, you can use custom answer checkers for lots of different things. One of them would be questions like this. You can also use answer hints to give customized feedback for particular kinds of answers. I can't remember if I did answer hints last week. Oops, I didn't mean next. Let's actually look at the problem source. So we're using the parser formula up to constant because we're talking about antiderivatives. And so we construct the general antiderivative as follows. In this particular question, one of the answers involves the differential dx, so we'll need to add that as a variable in the context. So you can have variables that have character strings that are more than one letter long, so you can have variables named alpha or delta or whatever you like, dx. All those things work. As far as the answer checking goes, the only special thing that's going on here is the custom answer hit that says that when the student enters a correct answer but has forgotten the differential, we're going to give them a custom answer hint that says, hey, don't forget the differential. So, for instance, let's just do show correct answers. In the second spot, we'd want 7 sine x. So if the student enters 7 sine x but forgets the dx, they're going to get this message that says, do not forget the differential dx. So hopefully the student interprets that correctly, enters the dx, and gets marked correct. All right, multi-answer answer checkers. These are a workhorse. They have lots of options, and you need to specify a custom answer checker. So in particular, a multi-answer answer checker allows you to harvest answers from multiple answer blanks and process them at the same time. Okay, so it's taking in multiple answers and processing them at the same time using a custom answer checker. So we'll use parser multi-answer to get that multi-answer answer checker. And here is the multi-ans object. It takes in a U and a DV as correct answers. And you have options for formatting the output. Do you want it to be on a single line or on separate lines in the feedback that gets displayed to students? Do you want to allow blank answers? No. A semicolon is a good separator, and in the tech output, we'll specify the semicolon as a separator for the two components. And then we need to specify a custom answer checker. Okay, so in this hash, we got the value of checker is a particular subroutine that takes in the correct and the student answers. And we will get an array of correct answers using this line. We'll get an array of student answers using this line. And we can specify error messages if the student answer is missing the dx, then the derivative of that student answer with respect to dx should be 0, and we can give them a custom error message in that case. We can do things like other custom checks. Yeah, so this is just taking the first two correct answers and student answers and multiplying them together and making sure that that if they're not equal, then the value that gets returned from this answer checker is 0. We do a bunch of other reality checks. Is the student formula answer a formula or a constant, or when we take derivatives of it, do we get a and then test if it's constant. Do we get 0 or 1? And then do a Boolean check on it. So you can basically take the student answer and verify that it meets a certain number of conditions, and if it does, then return a value of 1 for the answer checker. if we had used, up here, if we had used single result 0, then what we would want to return for the answer checker would not be the value 1, but instead a list of values. So you'd use square bracket 1, comma 1, end square bracket as the values for the first and second answer blanks separately. So you need to replace that here, and you need to replace these zeros with a square bracket list of zeros if you did separate answer blanks printed. Okay, scaffolding. So for multi-part problems where you want to hide successive parts, you want to use scaffolding. I would say it would be easy to overuse scaffolding. And in general, if you can write a problem without scaffolding, just keep it simple. The macros, the scaffold macro that David recently wrote and completed this past year is pretty awesome. It is super easy to use, and I wish it had been around a lot sooner. So as professors, of course, we have high permission levels, so we can click on these and open them up. But students would not be able to click these parts and open them until after they had answered previous parts correctly. Okay, so now we got the first part correct and the second part gets displayed. We would have the ability as a student to click on the first part and have that be displayed. There are options to this scaffold macro that allow you to set whether you want all the previous parts to be open or closed, things like that. So let's take a look at the problem source. It's actually very straightforward. It's amazingly straightforward. You load the macro, and then you begin a scaffold, you end a scaffold, and within that scaffold there are several sections that you need to begin and end. And within each section it's just a standard display text block, either PGML or begin text, end text. It's remarkably easy to do this sort of problem now. Okay, this is a problem I put together over this past weekend. Someone on the forums was interested in getting Desmos graphs into WeBWorK problems, and they're not working 100% yet. In particular, Desmos graphs often have a sort of algebra view with sliders and things, and I haven't figured out why this happens yet, but apparently sliders and things that are in that algebra view gum up the buttons on the WeBWorK page and make them unusable, at least on Windows under Chrome, Google Chrome. But you can make interactive graphs using Desmos, and there's an API for doing so. And you can, use these nice interactive graphs in HTML mode. Of course, you also need to think about PDF hard copy mode and taking a screenshot, including an image, and so on and so forth. I can't remember if I actually did that for this problem. I was probably lazy and didn't actually do that. But let's go ahead and take a look at the problem source. Okay, so I didn't load anything, right? I'm literally pinging a server out in Desmos land saying, hey, send me this JavaScript, and I'm going to interact with you using your application programming interface. Basically, I had to create an HTML element called a div in the page, and this identifier should be a unique identifier. So perhaps I should have identified this not by naming it calculator, but by something that would be unique. So in particular, the file name for this file would be unique to the directory that it appears in, so that would be a good choice for a somewhat unique identifier. And then you specify height and width. And then the only other special thing is how do you insert it? Well, you insert that div that we talked about earlier, and then you actually have to draw on it. So to draw on it, we are literally inserting a JavaScript that interacts with the Desmos API, and I would need to change the name of this ID here. I didn't think of this until now. I should change this to calculator-10-desmos1 to be consistent with what's up above. But basically, the Desmos API tells you to specify some options for Desmos. Do you want toolbars and things shown or not? And then you also need to set some expressions in the calculator. So you want to graph this function generated by the math object f. So we took the formula and used the string method defined on formula math objects to produce a string from this formula. And that string will have the values of m and b inserted into it already at this point. And so when we pass it to the Desmos applet, it's going to read that string and interpret it and graph it properly. Okay, so that's not, Desmos is neat. I'm not sure it's production ready yet. Okay, and now I'm going to get into a portion where I'm just not going to show you the source code. I'm just going to show off what can be done. This is a WeBWorK, a GeoGebra web applet that students can interact with. And much like the Desmos example, this applet is sort of standalone. If you want to talk with me more about embedding these things, I'd love to do that. There is a wiki page for, I forget if it's this particular example or ones very similar to it. There's a lot involved. In particular, one thing you'd like to have is that when a student submits their answer, that the state of the applet stays the same. So if the student has moved the cursor to 4.0 and they submit their answers, it's nice to have that state preserved. And in this particular problem, it obviously was not preserved because it went back to the default. So there are some hidden subtleties there to be thought of in writing these sorts of questions. Here's a GeoGebra web example that I wrote last year, and it's actually using GeoGebra to submit answers for WeBWorK. So in particular, you can move this circle around and click Submit Answers. And I don't know why this is not working.
It's because it's a live demo, Paul.
Oh, right. There might be a JavaScript collision somewhere going on behind the scenes. Anyway, it is possible to have the applet actually report a string of values to the WeBWorK answer checker, and then the WeBWorK answer checker, a custom answer checker, can be written to parse those values and evaluate the correctness. You can write custom answer checkers for differential equations. Much like we saw earlier, this is just a much more involved example, right? A third-order homogeneous differential equation. One thing I do want to point out here is a few things that I did. So the arbitrary constants in the problem are not arbitrary constants. I added them as real variables in the context. And that has a few advantages. I can substitute values in for them later when I want. In order to prevent things from being printed badly. I'm going to set some context flags. The real interesting part, though, is in the custom answer checker. Now, it's a big one, so don't be overwhelmed. Basically, I'm asking the students to enter their equation in the form y equals something. So I'm just going to grab the right side of their equation. That's the expression I'm most interested in. Then I'm going to take that expression and make sure it's got a constant C1 by differentiating with respect to it and making sure that you get something other than 0. And do that for the other 3 constants. Then, of course, you want to make sure that the student answers, the terms in their answer are actually linearly independent, and you need a Wronskian to do that. So I chose to evaluate that Wronskian at some point that is unlikely to be a singular value of this Wronskian. I substituted some values in for C1, C2, and C3, and got some numerics, some numerical entries. The first, so I'm building up a 3x3 Wronskian matrix, one entry at a time, with these 9 lines of code here. And then when I first did these answer checkers, I thought, oh, well, I want to know, is this Wronskian 0 or not? Well, guess what? 0 level tolerance is kind of a pain in WeBWorK. It's very sensitive. So instead of checking whether or not this expression I've highlighted here is 0, why not take that expression equal to 0, rearrange some of the terms, and get something non-zero on both sides of the equation? So that's what I did here. Rearrange the terms so that I've got non-zero things on both sides of the equation, and that's going to make the answer checker a lot more reliable. Okay, then if you want to actually, if the student answer is actually independent, you want to also verify that it satisfies the differential equation. So I took some number of derivatives of the student answer and plugged them into the differential equation. And again, when I started doing this, I would check whether or not the student differential equation was actually equal to 0, and I realized this is not the right way to do it. Rearrange the terms of that equation so you get some non-zero things on each side, and then the answer checker is going to be a lot more reliable. And I was struggling for the longest time trying to get this other equals 0 method to work, trying test points, trying all sorts of things, and it just dawned on me, well, duh, do it this other way where you got non-zero things on both sides of the equation, and the answer checkers became immediately much more reliable. A few things I want to show off. I'm not going to go into detail about them. I was working on some stats problems this past semester, so I wrote up how to do some histograms and bar charts, just using the basic PG graph macros, dot plots, same sort of thing. This is a D3.js experiment that I did this spring. And much like the Desmos example, you create a div on the page, and you call the D3.js script, and you set up some values for it, and it takes care of the rest. The downside of this is it's beautiful in HTML mode, but how do we actually get it to do anything interesting and randomized in the PDF hard copy mode? So that's maybe one of the challenges that WeBWorK will need to face next. And this was the fun thing that I did this past weekend. So this is totally brand new. This is a D3.js graph in the network sense of graphs. And as you can see, you can drag things around and they'll stick where they are. If you double click, it'll release it. I can be more dramatic than that. So there you can see when I double click and release, it's very interesting. And this allows for rearranging the graph in ways that the student might find helpful. So I don't know, I'm thinking maybe we could get this worked up into some sort of macro eventually so that combinatorics and other types of questions could use it. Other types of courses could use it. And also for fun, this weekend I wanted to document David's chemical equations context stuff. So there's an example of that there. This example is directly from my stats course this past spring, and I wanted to show it off to you because I've got an internal link here to an HTML file that is in the same directory as this PG source file. And if I click on it, it's got some pre-formatted text, which students can then copy and paste into whatever. In our case, our stats course is using Applet to process things in that particular form. Before passing the torch on to John to highlight some of the work that he's done, I want to just briefly look at this and show how that was done. Okay, so let's go to here we go. It's done using just a straightforward HTML link. And because I placed the HTML source file in the same directory as the PG file, I can use this command called alias and call that on the HTML file, and it'll fill in the directory information necessary to find where that HTML file is and create a link. Okay, so the new wrinkle here is using alias to access an HTML file in that same directory.